Good morning. So it's sad for me because this is the last unit we're going to be doing together before the end of the year, but I'm sure you all are probably pretty excited to be finishing your freshman year. As you'll notice, this last unit is on radicals. We're starting with lesson 11.3 because the first two lessons have to do with the real number system, which we did way back in the first semester. So we'll start with 11.3 and we'll be going through 11.10 with this unit. We will take one more test before summer break. So today we're going to look at some terminology for this unit on radicals, and we're going to look at perfect squares, and then we're going to start solving radicals that are not perfect squares by looking at the best method to do that. So our first term is square. Square means the product of a number in itself. For example, 6 squared means 6 times 6 or 36. 10 squared means 10 times 10 or 100. Square root, one of the two equal factors of a number. For example, the square root of 9 is 3 because 3 times 3 is 9. The radical sign is the symbol used to indicate the square root of a number. What is inside is called the radicand. Perfect square, a number whose square root is a whole number. Example, 16 is a perfect square because the square root of 16 is 4. 4 is a whole number, not a decimal or fraction. All right. So now we're going to get a little visual here on squares and square roots. How to square a number. To square a number, just multiply it by itself. We've been doing this throughout the year, really. So 3 squared means 3 to the second power, which is 3 times 3, which is 9. In visual form, you have a square, and it's broken down into 9 smaller squares. So it's 3 units on each side, so 3 squared is 9. Okay. Perfect squares are squares of what kind of numbers? Whole numbers. So whole goes in there. The next part says complete the table. If you don't know your perfect squares through 20, it's a good idea for you to go ahead and commit those to memorization. It's just good to know, and it's fast practice. I'm not going to do it to expanded form, but 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. So that's the first 10, but let's go to 20. 11 squared, 121, 12 squared, 144, 13 squared, 169, 14 squared, 196, 15 squared, 225, 16 squared is 256, 17 squared is 289, 18 squared is 324, 19 squared is 361, and 20 squared is 400. I do feel like there was an earlier time this year that you all worked on perfect square numbers, so I feel like most of you probably already know these. Okay, let's go on to the next page and talk about square roots. When we talk about square roots, it says 3 squared in blue is 9, and then you can work it in the other way. So let's see. So when we square 3, we get 9. When we take the square root of 9, we get 3. A square root goes the other way. 3 squared is 9, so a square root of 9 is 3. A radical is used to show the number square root. The radical is used to write the principal or positive square root of a positive number. The square root of 49 equals 7 is read the positive square root of 49 equals 7. The opposite or negative square root of 49 equals negative 7, and it's read the negative square root of 49 is negative 7. In the expression, the square root of 49, the number inside of the radical is called the radicand, and I mentioned that on the first page. So the 49 is the radicand of the square root of 49. We have a couple properties that we're going to look at before we get started in doing some practice. It says for all positive real numbers A, every positive real number A has two square roots, the square root of A and the negative square root of A. The symbol square root of A denotes the principal square root. 0 has only one square root, namely 0 itself. The square root of 0 is 0. Product property of square roots. For any non-negative real number A and B, what it's saying, if you have the square root of something, you can break it down. So let's say we had the square root of 32. We can break this down into the square root of 16 times the square root of 2. Because 32 is not a perfect square, but there's a factor in there, such as 16, that is, so that helps you be able to simplify it. That's what that property says. Quotient property of square roots. For any non-negative real number A and any positive real number B, the square root of A over B equals the square root of A over the square root of B. So let's see. An example of this might be the square root of 2 ninths. Why would I want to separate that? Well, the square root of 2 is not a perfect square, but the square root of 9 is. So I could leave that as the square root of 2 over 3. So that's kind of what these properties are used for, and we'll get into them more as we start simplifying. Practice. Find the indicated square roots. If you cannot see any squares that divide the radicand, find the prime factorization of the radicand. Okay, let's do some practice. So number 1. The square root of 324. If you go back to your perfect square table, which we've only done through 20, we see that 324 is a perfect square, and that's 18. So that's all it's asking us to do to simplify. All right. Number 2, the square root of 1600. All right. So our chart doesn't go up that far, but it says if I can't just immediately know, divide, find the prime factorization if you need to, or find two factors that are perfect square factors. So what comes to mind is 100 always, and 100 times 16, both of those end up being perfect square factors. The square root of 100 is 10, and the square root of 16 is 4. So the square root of 1600 is 40, but we were able to determine that without just knowing that through the tables. All right, let's go to this one. There's a little bit more to this one. We have the square root of 2,304. Wow, okay. So what do we do there? What helps us? We know it's even. If we add the sum of the digits, what do we get when we add the sum of the digits? We get 2 plus 3 is 5, plus 0 plus 4 is 9, okay? So we also know that it could be divisible by 9 as well, and that could help us along the road. If we just start breaking it apart by even numbers and taking half, we get 2 times 1,152. Okay, that's prime. If we break down 1,152, it's even again. We get 2 times 576. Okay, so we broke that down again. If we break 576 down again, we get 2 times 288. If we break 288 down, we get 2 times 144. And right here, I'm now to something in my chart that I know is a perfect square factor. It's 12. So let's look at how we can write this and what it means. So we have 1, 2, 3, 4 2s. So I can write this really as 2 times 2 are 4. 2 times 2 are 4, and 144. So I've just rewritten these as factors of 4. Why? Because these are easy to do. The square root of 4 is 2. The square root of 4 is 2. The square root of 144 is 12. 2 times 2 is 4, and 4 times 12 is 48. This isn't the only way to do it, but this is one method. You might have chose 9 and then found the other factor times 9 that makes that true, and gotten to the gotten to 48. But again, this was a perfect square. We just didn't know it by doing it by hand until we were able to break it apart. Okay, the square root of 36 over 121. Whenever you have a quotient, it's always good to see if you can divide the numerator and denominator or simplify it in any way, which in this case, I don't believe you can. It doesn't go in evenly, but I can use the property that says separate the radical to the numerator and denominator. That's a great thing to do because the square root of 36 is 6 and the square root of 121 is 11. All right, let's go to the next one. 144, so this has positive or negative in front of it, and that's okay. Square root of 144 over 3025. I'm going to go ahead and break down the radical to the numerator and the denominator. So I have positive or negative 144 over 3025. 3025, I don't know if that's a perfect square, but I do know it ends in a 5. So 5 times 605 is one of the factors. Then I know that it still ends in a 5, so that's 5 again, and 5 times 121. And I know 121 is a perfect square. So now I can rewrite this as the square root of 144 over the square root of 5 times 5 is 25 times 121. And the square root of 144 is 12. The square root of 25 is 5. The square root of 121 is 11. So this answer is positive or negative 12 over 55. Okay, I have one more here. Number 6. The square root of 729, and this is the negative square root of 729 over 3,364. Okay. Oh, actually, I have a couple more. I think there's 2 more in this section. I thought there was just 6. So let's look at this one. And when I look at this one, I see that 729, I don't know if that's a perfect square, but if I break it down, I know it's divisible by 9, and 9 times 81 happens to be 729. Okay, now I'm going to break down 3,364. So I'm looking for factors again. I know 64 is divisible by 4, so I'm going to choose 4. And I'm going to choose 4 and 841. 841. And then I know that I can break down 841 again into, looks like it is that a 29 times 29? 29 times 29. So then from there, I have 4 and 29 squared, really. So I'm going to just call that 4 times 29 times 29, which is 841. Okay, so on the top, I end up with the square root of 9 is 3. The square root of 81 is 9. So that's the negative on top. The square root of 4 is 2. The square root of 841 is 29. So this gives me negative 27 over 58. I'm not sure we can do anything else with that. Okay, I'm going to have you try number 7 and 8. And then when we come back on, let's see if you all are able to get these. The square root of 9 hundredths. Actually, I might do these with you, because for this one, I would go ahead and call this the square root of 9 over 100. And then I can separate that into the square root of 9 over the square root of 100. And the square root of 9 is 3, and the square root of 100 is 10. So you get 3 over 10. The last one is the square root of 7 over 175. The question is, does 7 go in evenly to 175? It does. It goes in 25 times. So I can simplify this one to 7 divided by 7 is 1.